Hi, this is James Benjamin. We are going to do a couple runs on something called Statcheck. One of the things that I would definitely recommend doing at some point um, while you're working on this assignment or after you've worked on this assignment is to go ahead and actually um, click on the link that says more information about the program here because the manual is pretty useful and thorough in its own right, and it'll give you some ideas of what this particular program can do and what its limitations are. Okay, because like everything, there are limitations. Okay. Um, and anyways, for the assignment, what I've done is I've given you two different documents. And the documents are ones in which you have the are ones that offer a contrast. One is might have a minor error or two. The other may have some more serious errors. And so part of, I think, your training and becoming better critics of the science of psychology is to be able to spot potential problems in data analyses that you are reading, that you are consuming. Okay. And so, anyways, the way this works in a nutshell is that you upload a document, a paper, and again, you can kind of see that you can upload through the following formats, either PDF, which is probably preferred, or HTML, or as a Word document, and it will look for any statistical test it can read, and it will tell you not only the statistical test as reported by the authors, but also the p-value the program was able to calculate precisely based on information such as degrees of freedom and so on. And of course, the type of test, whether it's an F test, T test, etc. And of course, the test statistic value itself. It'll give you that information. And then furthermore, it'll tell you is the finding that the app came up with consistent with the reported p-value? Is it inconsistent, which could simply mean that there might be a rounding error or something along those lines? Or is there a decision inconsistency, which would mean that something a little more serious has happened? In other words, a researcher might report something as statistically significant that's not that's actually non-significant, or they may have reported something that is non-significant that really is statistically significant. And when you get those sorts of discrepancies like that, that can change the really the conclusions that the authors would wish to draw, and in fact can end up entirely invalidating the article itself, or at least the author's argument in the article itself, which then suggests another set of processes that might need to be taken. Okay, so that's the idea. And so let's go ahead and run through a couple of these things, and I'll tell you how to use this, or at least get the best use out of it. Part of this is actually pretty easy, and then the harder part is actually doing just a little bit of detective work to matching lines in the output here with lines in the with actual tests in the paper itself. So I'm going to go ahead and try to find. I need to get out of one of my get the documents here. And I will get to experimental psychology, find my stat check assignment. And this one is under Guo and Egon. This is from 2016. The authors um, had some highly provoked individuals exposed to aggression inducing stimuli or neutral stimuli. And then they were also were manipulated to either have high or low locus of control. Okay, so that's how that works. Now, once I upload the paper, as you can see, I can choose how many entries that I actually want to um, show. And I can show as many as 100 entries at one point if I want. But what you can see here is that everything looks, well, most things look pretty good. You see mostly reports of consistency. I do see some reports of inconsistency. I see two specifically, but these look like fairly minor. Well, one looks fairly minor. One looks like definitely a major typo. One is a rounding error. The other, somebody added an extra zero they didn't need to be adding. Okay, and given the degrees of freedom I'm looking in the F test here, if you've got an F of 9.22, yeah, this is probably a more reasonable p-value than the one that was reported as 0.04. Now here, this is, I'm guessing, just a simple rounding error. But let's find out. And so what I'm going to do is I'm actually going to go and I'm going to read through the results section of Guo and Egan. And so let's take a look here real quickly. And it looks like that when I go through this, the participants who saw the kind of going through this, the manipulation check is fine. So really where we run into our first potential issue here is, let me find it, go back to stat check. And so let me find, yes, this is actually for study 1, by the way. What I find, again, is when they say that the main effect of sense of control was significant. That one seems to be where there's a minor inconsistency. When we get to the test where they look at simple effect analyses indicating that exposure to aggressive cues increased aggression for adolescents in the low sense of control condition only, where they report a P of 0.04, it really is more of a 0.004. So it's an inconsistency, but in each case, these are not inconsistencies that will change the basic meaning of the results. All right. The arguments the authors will end up making in the discussion section will be perfectly unharmed. That's something where you might write the authors and say, hey, I noticed these minor issues here. Don't think these really change your paper any, but you just should be aware of them. Okay, and that's not that big a deal. Okay, so that is something that you could do on yourself, uh, or by yourself, I should say. Okay, now let's take a look at the other paper, because I wanted to give you one that I thought would be a good paper. Now let's go ahead and give you something that is a bit more um, egregious. Okay, by the way, one of the things you'll want to do, make sure you download your results. Always an important thing to do. All right, and it'll just simply give you a generic stat check name. You'll probably want to go ahead and give it a different name, like Woe et al. Or something like that. Now I'm going to go ahead and I'm going to reload, and then I'm going to browse again. Since I'm already in this folder, I'm going to go ahead and this one with a really funky name, I'm just going to go ahead and select it. And this is one by Tian Zhang and some other colleagues out of Southwest University in China. And what I'm going to show you here is their particular set of findings. Okay, and what you will notice is that some of these look consistent. Some of these you see some serious decision inconsistencies, which of course would be very concerning because these mean that whatever numbers that the authors have put in here are entirely wrong. Okay, so for example, just to give you some idea, if you've got a F value with these degrees of freedom this low, you're probably not going to have a statistically significant finding, certainly not at p is less than 0.01. With these degrees of freedom, the same thing here. This is going to be something that's definitely not going to be at p is less than 0.01. It would be it's not going to be statistically significant anyways. Okay. And again, you see another one where they've got an F of barely over 1, and they report it as statistically significant when there's actually no way, unless you had just several thousand participants in a sample. No way is that ever going to be significant. Okay, so these decision inconsistencies would be troubling. One of the other things you should probably note is I'm going to tell you in just a little bit the number of participants that are in the study, which would suggest that the degrees of freedom would be entirely off the wall, anyways. You're going to want to note that there's probably more than just some decision inconsistencies going on here. There are some serious typos that make me wonder how this actually got past peer review. Okay, and again, this is one where the researchers had participants view either a clip of a violent film or a clip of a nonviolent film. All right, so that's basically it. So that's the idea here. And when I look through the data analyses, okay, one of the things they try to do is they try to establish that their main effect of movie violence on aggression worked, okay, which looks consistent. But one of the things to keep in mind, the denominator term here of 66 degrees of freedom makes absolutely no sense when you realize that there were let me take a look here real quick. I like to make sure I get this correct. Um, 188 undergraduate students. All right, so if you've got 188 graduate students, all right, you're not going to get that kind of degrees of freedom. Um, for the kind of analysis they did, um, you're going to have, overall degrees of freedom of 187. When you realize that you've got numerator degrees of freedom for main effect one film as one uh, grade, apparently freshman, sophomore. That's one of the ones they had. Personality, aggressive or non aggressive. Um, okay, you're going to have those. You're going to end up with something more in the neighborhood of maybe 184 degrees of freedom at most. And they mention grade here at one point, then they refer to gender elsewhere, which I find rather strange as well. So clearly, there were some mistakes made in this paper that go way beyond anything Statcheck can do. But when we find our first decision inconsistency, what they try to state is that it's right at page 38, and they state a significant stimuli type by gender interaction was found. And then they list the F of 1 with what they claim is 157 degrees of freedom. That's 1.67, p less than 0.01. That was a decision inconsistency, which means that in reality, this would be non significant. Even with 188 at 4 degrees of freedom, this would be definitely non significant. And further simple effects analyses indicate that the what they really is a difference score um, between reaction times on aggressive versus non-aggressive words was significantly smaller when exposed to violent stimuli than when exposed to non-violent stimuli. This is for males. They claim here an F of 3.41, P less than 0.01. That's, to be quite honest, that's not going to be quite significant either. So they really end up with a couple decision errors right off the bat, and it makes sense actually. By the way, if your two-way interaction is non-significant, there's no reason to calculate simple effect or simple effects because none of those are going to be significant either. All right, so you can see that already one of the arguments they want to make in saying that, look, these stimuli seem to be affecting young men, maybe not young women, but young men definitely. They really can't make. Okay, we can't accept that as consumers of the research based on the evidence that we have. The other decision error occurs a little bit later on. They claim to have found a movie type by aggressive personality interaction. And so they, um, report it. And again, clearly, when you look at what Statcheck says, the p-value for that would be about almost 0.07. So actually, let me go down a bit. I got that a little bit wrong. More like 0.18. Excuse me. Need to scroll down. So clearly there is a problem there as well, right? So at bare bones minimum, some sort of typo happened. or maybe a lot of typos. It's really hard to say. This whole paper, as you probably read through it, looks like a bit of a mess. All right. Now, one more thing I want to note is that for Statcheck to work, you have to have not only the reported, F statistic, but you really do need to have the degrees of freedom. And the authors in this paper report a three-way interaction among movie type, aggressive personality, and gender. And they report it as 6.43, and they claim that the p-value is greater than 0.05, which I find hard to believe on the face of it. Again, with degrees of freedom in the denominator term of about 184, that would be a statistically significant result, which tells me something very important, that if that number is correct, if that test statistic is correct, they somewhere have a three-way interaction that they need to be reporting and trying to interpret. And if they had found nothing significant for real, and we could look and say, yeah, this looks like something that is not for real, then that would be another story altogether. We could just simply hang up our spurs and go home, as it were. But we really can't do that. So that's a real problem with this particular analysis, is that when you get to the discussion, really practically anything the authors wish to state is entirely invalidated. And the table 3, by the way, is completely nonsensible. We're not entirely sure what they were trying to get at with this, but there's no way that any of that would have made sense, okay, given everything else they've been reported. They're reporting different scores. These means would make no sense, and so on. And given that there's really, by the time they're all is said and done, they're only really dealing with these different scores and doing their analyses on those, rather than, say, a more complex analysis where they look at the interaction of the aggressive versus neutral word reaction times, which they didn't want to do. I can understand why. That's complex. The main thing is that there's just no way that those means could work in Table 3. So we don't know what the authors were doing there, but they did something. I'll give them that. Your job when you're doing these, and again, remember, make sure that you save your results, but your job is to then, give me a nice, healthy paragraph about each of these papers. Give me several sentences where you summarize what happened with these particular papers, the one by Guo and colleagues and the one by Tian and colleagues. The idea, of course, of having media violence research done outside of American and European countries is not only laudable, but absolutely necessary. But we also want to make sure that these are done correctly, just as there's a lot of really faulty research in the US and the EU, and I've seen it. It is possible to happen in China as well. And so, really, again, I know that the part that can be a little bit of a pain is, going through and figuring out where which test in the paper the decision inconsistency was really tapping into. But that's okay. That's not a real big deal. The big deal is to be able to look through and say, yeah, I can see how this is a problem. Yeah, I can see how, in the case of one paper, the Tianadol paper, that um, it probably should be retracted, or at least corrected if the journal editor wanted to go that route. Um, Typically, journal editors, if there's a situation where the findings, the mistakes invalidate the paper as it was written, they just simply want to retract it and be done with it. But some will go ahead and offer up something of an olive branch, if you will. Whether that's good publishing practice or not is debatable. Um, but anyways, what I want you to do is, go through, do these runs, upload the spreadsheets you get for Statcheck, um, and then make sure that you give me some sort of um, set of paragraphs that demonstrate that you made some effort to understand what you were getting from the Statcheck runs, and that you were able to at least understand what the papers were finding and what they were arguing and whether their arguments still made sense or not. Okay, so that's really what I want you to do. You do that, we're good. All righty. I'll have another tool that you'll be able to add to your BS detector, hopefully next week.